Well, welcome to another tutorial. In this lesson, we're going to talk about Section 5, as I like to call it, or Chapter 5 in Test Out, whatever you prefer to call. This is going to be on IP addressing and the many aspects that you can see. So we're going to talk about IP addresses first. And basically, we're using TCP/IP, and that's going to be something that totally uniquely identifies a host, and that's based on layer 3, the network layer in here. So it's a series of four numbers separated by dots. Each section has 8 bits, and it's in decimal in the range of 0 to 255. So you can see 167.12.155.16 is an IP address. So and then each position is called an octet. So here you have again that IP address over here. Everything is from 0 to 255, and you can see 12 is called an octet because it is a series of 8 numbers. And if you're going to convert binary to decimal, using this table over here is very useful. So you can see the binary numbers are already labeled. So what you're going to do is just do a simple division and subtraction, which you'll see in a slide. So if you were to add all these numbers up, that would be your decimal numbers, the ones that are up here on the top. Now you're going to look at the values of the tables. So whatever number we have, the very first thing you're going to do is say, will 128 go into that number? If the number will, then you put a 1 in the 128 spot and you subtract. Say the number is 200, you would subtract 128 from 200, and whatever's left over, you would look and see what is the highest number that can go in there. Anything that doesn't have a 1 in it is going to have a 0 in here. The subnet mask is what determines the difference between the actual network itself and the host. Wherever there's a 1, that is part of the network. So you'll see that in a subnet mask, that's going to be a digital number from 0 to 255. Again, it has 4 octets. You cannot have any embedded zeros. As soon as the first number becomes a 0, everything else has to be a 0. So you could never have anything like 11011. It would have to be 110, and then everything else after that would be 0. Now, these addresses can be either manually assigned statically or automatically through DHCP. So again, here you see 167.12 again, and you have 255, 255. So 255 is all ones. It's 8 ones. That would mean the actual network would be 167.12.0.0. And the host could be the ranges, the last 16 bits in here. We're talking about classes. Now, we don't really use classes much more because they are really a waste of IP addresses. Everything is done now through CIDR notation. But if you have a company or a situation where you need classes, remember you just look at the first octet. If it's from 1 to 126, it's Class A, 128 to 191. Class B, 192 to 223 is Class C, 224 to 239 is Class D, which is multicast, and 240, 255 is for future. Notice there's no 127. That's because that's reserved for loopback. So again, Class A share the first bits 0 to 7, Class B first 15, and Class C the first 24. When I said 15, it's 0 to 15, so it really should be 16 altogether. And these are your Class A networks and their subnet mask again. And this is the number of hosts that you can have, which is a lot if it's Class A. Mostly you're dealing with Class C, which is 254 hosts. There's actually 256 valid addresses. However, you can't use the first and you cannot use the last. The first is reserved for the network, the last is reserved for broadcast. And the special address 127.0.0.1, that basically temps, it's a troubleshooting tool and it helps you to test your connectivity. ipconfig is what you're normally looking to see if you can connect to another computer by pinging it, or rather ipconfig, sorry, that is gives you information about your workstation. Ping is what gives you information about So we have a broadcast address is the last address, and it identifies all hosts on the network. So if you need to do something, you'll send it to every single network host. Okay, signing IP addresses, that's all done from IANA, ICANN, and RIR. Those are the regional things. The ICANN is the one to develop it, and the INAA is the Internet Naming Authority. So basically, you're going to use a company individual. You get your IP addresses, the public IP addresses, not your private IP addresses, you get from your internet service provider. They'll give you blocks of them. They may give you two, they may give you four, they may give you eight, and that determines that you pay for each one. But all your IP addresses that are private are going to go out on a public IP address. Every network node must have a unique IP address. If you don't, you're going to get an error on there. So that's why it's dangerous to be giving out static IP addresses. They are reserved for servers and for printers that cannot have their IP address changed. If you have 75 workstations, you would have to go to each workstation and manually configure it. And then what happens if you did the same one twice? You get an error. Then the advantage of TCP over here again. Uh, this is our connection. It's costs nothing to use. It's flexible and it's routable. That means if you need to go from one network to another, one subnet to another, or out on the internet, you can use that to go. And TCP is a transport layer protocol. That is the one that's secure. It provides sequencing and checksums when you're transferring data between two computers, when you're connecting to a computer, when you're doing something important. A connection must be established that is going to guarantee data that's going from one to the other is going to be accurate. And this is what the segment looks like. So you can see it's going to have a source and a destination. The sequence number and acknowledgement are through part what's called a three-way handshake, which you'll see in another slide. And then it's going to have all your data put in there, and the checksum is also for to check to make sure the data is accurate. So you have the three-way handshake. Computer A says I need to connect to computer B, so it sends out a message with the sync bit set, and that's nothing more than a random number, a whole bunch of numbers in there. And then the computer B says, okay, what it's going to do, it's going to acknowledge it by adding 1 to the sequence number that computer A sent. And then it's going to send out a sync with a random number. So computer A is going to respond basically the same way. It sends it in there to the acknowledgement by adding 1 to the sync, and then it puts another random number out, and an FN flag means okay, everything's established. And here's how it works. So you can see that the sync number is 937013558, and then the acknowledge is one more than that. Okay, UDP is when you go to YouTube or you're looking at a video somewhere else. You can't handle error correction because it would just take forever to do it. So it's just going to download whatever you get in here. And you're going to want to do that when you're transferring huge amounts of data. Okay, and this is the UDP section. Notice there's no sync, acknowledging, checksum, or anything else. It's just there is a checksum, but not used in the matter of error checking to make sure that everything's fine. It's basically just there for corruption. Okay, network layer protocol. So you're going to have TCP/IP on that one. That allows you to go to different networks itself, and that's done by an IP packet and what's called a data envelope. You'll see all that in the video, exactly how the data is formed into packets in a transport layer. IP is two versions, version 4, version 6. Version 6 is newer. That's 128 bits, where IP version 4 is 32. The videos again show that as pretty good sense of exactly how it makes out. And the advantage is IPC is going to, you're never, ever, ever, ever going to run out. Okay, again, we're using IP4 addressing most of the time, so it recognizes it as either a logical or physical. The logical is the address itself. The physical is the MAC address, which is 8 pairs of 2 bits, rather 6 pairs of 2 bits. And you can see that an example of the IP address. The DHCP is a dynamic host protocol. It's at the application layer, and that's going to hand out IP addresses. Okay, so what you're going to do is you're going to connect to an DHCP server. Then you're going to give it a lease time, which is normally 8 days. That's a default for a workstation. After a certain period of time, the workstation will request a renewal. That saves everything happening all at one time. And if the DHCP server is down, it'll request again. You may want to change the lease time to 1 day or even several hours if you have a wireless network and you don't want people tying up leases. So again, this is how it works over here. You can terminate a lease when it expires, or you can manually terminate it. On either way, you can type ipconfig/release in the workstation or the DHCP server. You can just delete it. This is how it connects. It's called DORA, which is discover, offer, request, and acknowledge. A DHCP relay, that's where you have two separate networks connected with a router, but you only have one DHCP server. So you need to be able to get IP addresses from people that are on the network that's not on the same as where the server. The relay will do that for you. And again, configuring a relay agent is not very difficult. The next slide is going to be set up, and you right click, you add the new routing protocol, you set up DHCP relay, then relay agent, new interface, choose a network, choose relay properties, and the video again takes you step by step in here. DNS is going to resolve names to IP addresses. Microsoft.com, it's got an IP address, so when you connect, you physically connect to the IP address. Why can't you just memorize the IP addresses? One, it's very difficult to remember everything, but two, the IP addresses constantly change in here. So what we want to do here is take a look at how everything is set up so that the top is a root, underneath it is .com, .edu, .gov, and all of the other second layer domains, then Microsoft and my company. So you would have Microsoft.com, and at the end is a dot that signifies the root. Underneath that, you can have separate subdomains like accounting and sales, and underneath that, you can have more. Then the host itself is at the very beginning. So host1.sales.mycompany.com, the actual host is host1. The fully qualified domain name is the host and the actual domain itself. A DNS zone is basically under the control of a server. And so you'll see things that are authoritative and non-authoritative. That all has something to do with zones. There's primary zones, there's secondary zones, there's stub zones, all kinds of zones which you'll see in the DNS video. The way a computer tries to resolve a name, it goes to the host file first. If the host file exists, it will put it there. However, that's not a very efficient way of doing it. Primarily, you want to go to your local DNS server. That's going to be authoritative or responsible for all the names on the network that it resides on. If you try to go to Microsoft.com, testout.com, Google, the DNS server is not responsible for it. It's going to get its information from another server. So it will originally get it and go out to the top level domain for .com to find where Google is. And what's recursion is where if it doesn't find it at the top, it's going to keep going down until it gets it. So the top level will say, no, I'm not responsible for it, but here's the next layer. And then it'll go to the next layer and say, no, I'm not responsible for that, but it'll give the address of the next one until it finally finds it. That's where the recursion keeps going. It's going to keep going back and forth until it finally does the actual answer. So you can see here, it's going to go all the way up to the root, and the root's going to say, well, here's org, and then org's going to say, well, here's this, and here's the authoritative until it gets to the authoritative server for CompTIA. Obviously, one of the org servers cannot give every single domain that has an org. It'll be just too much. So it's broken down. That's why you're going to keep going till you get to the regional area that does that. Caching only server, basically it doesn't have zone information, but it just gets them from another server. And that's for efficiency. Dynamic DNS, DDNS, that's where whenever you make a change in a Active Directory, so you add a new workstation or the IP address changes for some reason, it will automatically get updated. Okay, we know about domains, domain names, and fully qualified domain name again, blogs.loc.gov. Okay, again, it's a label which is nothing more than a character string separated by dots, such as www.google.com. And again, the top level domain is com. Secondary is Google. Third level is www. Then these are domain names, basically the the ones that you're most familiar with: .com, edu, gov, org, net. And host and domain name restrictions can be up to 253 characters, hyphens, underscores, periods in a name, and no special characters. ARPANET is something that originally came around, and that was in the 1967 to 69. And basically, it was something that actually used text host file to do it. And you'll see in the slide, the next slide, exactly how that works. So we have a Windows computer is going to have a host file, and it's located in either in the Windows folder, the System32, or in a Linux system in the ECT directory. So you can see it has an IP address, it has a name, and then it has an alias if you want. But the reason why you don't want that is what happens if Cengage changes to .80. You'd have to go to every workstation and change that. So DNS resolvers, name servers, and namespace. So the name servers are basically just associated database of names. A namespace is an abstract database of internet IP addresses. And here's how that works. Okay, again, here's your resource records, which is an A record, which is the most common. AAA is for IP6. CNAME is a conical name or just a nickname. MX is for mail record. And pointer does the exact opposite. It's going to give you an IP address to a name. Configuring DNS is fairly easy. It's pretty much next, 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 next. You have to decide whether or not you want to be Active Directory and do you want to replicate to all your servers. Other than that, it's very easy. We talked about private addresses in here, and here is a PIPA. Anytime that you have a DHCP problem where you can't connect, you're going to get an PIPA address which begins with 169.254. The reason for that, it at least allows networks on a segment to communicate with each other, but they won't be able to get network resources or they won't be able to get out to the internet. Sockets and ports is really just a process that's assigned a port. A specific process gets a specific port, and a socket number is just the port plus the host machine address. So that's how you know what's going on. For instance, Telnet goes out on port 23, so the actual socket's going to be the IP address, and notice the double colon 23. And these are the port ranges over here up to 65,535. These are common port numbers. If you're taking the CompT exam, you probably want to know many of these right here. Telnet is where two computers can connect to each other. It's not very secure, so you want to be very, very careful on that. There's much better methods of doing that, but primarily it's a quick way to connect to a switch or a router to make changes in there without having to physically be at the switch. FTP is how you do file transfer protocol. So when you download a file, it's being done under FTP or secure FTP. NTP allows a server or a computer, if you're not on a network, to actually get the time on a computer from an internet. And there's several ways that you can do it, several places that you can go. If you're on a server, you have your main server is going to connect to and get its time from that, and all the workstations will automatically, if they're on a domain, will automatically get their time from that computer. Ping is how you can test communication between two devices. So if you ping an IP address and you ping a domain name, you should get a response. And this is what it looks like. That was my phone. Please forgive me. You can see how they ping 140, 147, 2497, and it replied with 32 bytes. The time was 47 milliseconds, and the time to live was 243. The time to live is necessary to keep, if there's no response, to stop the packet from trying to find it and live in internet forever and ever and ever. So you can see, and the other one, the request timed out. Okay, so the summary, make sure that you know protocols, TCP, UDP, IP, IP4, IP6, DHCP, and DNS. So hopefully this is helpful. Have a wonderful day.